AgSat has a PhD from University of Waterloo in applied mathematics. And he worked in an environmental and geophysical fluid dynamics group. He's currently a full-time software developer at Aquanty, and he enjoys coding in C, C++, C#, Python, Go, and JavaScript, as well as Node.js. So without further ado, Derek, on to you.
Thank you very much for the nice introduction, Amir. Yes, I am Derek Steinmoeller, and I'm here to tell you a bit about Aquanty, what we're all about, and then I'll lead into the challenge use case there. So Aquanty is a research spinoff from the University of Waterloo Earth Sciences Department. It was founded in 2012 by Dr. Ed Sudicki and his lab. So our staff are experts in hydrogeology, contaminant transport, soil physics, climate change, applied math. That's my niche, and integrated climate, surface, subsurface modeling, etc. So our flagship hydrologic simulator is HydroGeosphere, and it has about a 20-plus year development history and provides robust coupled surface water, groundwater simulations. So these are not like the machine learning models we know and love today. These are physical models where it's like a weather prediction scheme. You kick things off with some initial state, and then its state forevermore, as long as things stay coherent and don't blow up. So that's HydroGeosphere. Can we move on to next slide, please? So Aquanty sort of focuses on a few different verticals, and I think this slide illustrates it well. On the left, we have our HydroGeosphere integrated hydrologic models. So these look at fully or variably saturated subsurface flow, things like fracture flow and hydrologic prediction and estimation, things like water availability, water quality, and we've also within the past 5 years started looking at climate change impacts, so mid and end of century impacts with various climate scenarios and downscaling to drive these regional simulations that in turn couple into HydroGeosphere. In the middle, I'll move on to what I think of as my baby, or I guess it's a shared baby, but it's one of my web products that I helped develop or developed most of it. It's AgSat Farm Data Essentials, so that's agsat.ca. What it does is it's an aggregator of free and open source data products that are made available by the government, or some of which are available through other open data providers like European Space Agency. Let's aggregate all this data. Let's not tell first responders to run. Just empower them to make decisions on their own by giving them. And you also get access to these remotely sensed data products like crop soil inventory. We're looking to add biomass and other things as we go along too. And finally, last but not least, is HGS-RT, HydroGeosphere Real Time. So this is the whole forecasting platform that's been developed since I've been around, but I helped get onto the web, and I can't take credit for any of the forecasting aspects. So what you can do with HGS-RT is stream flow, soil moisture, and groundwater forecasts all within the same model. So the idea and it's to predict urban and agricultural conditions. So you see on the right of the logo the crop crop field there that shows a high resolution imagery. It's a true color image, about 70 centimeters in resolution. So each pixel 70 centimeters across. This might appear in training data and certain challenges. And there's also analytics toolboxes related to telling you about growing degree days. So how many days above 15C did I get over the growing season? And that's a cumulative thing that you can look at for your area of interest, which corresponds to a farmer's field, right? And on the right, we have the precipitation tracker that measures how much precipitation occurred over that area of interest. So just integrating for my mathematical friends in the audience. So there's also other tools embedded in there. There's a note-taking feature for daily observations or anything you want to write about your property. There is an imagery. There's the imagery store and the imagery library, which are obviously very closely related, and you can look at any image you've bought from the store. And then there's this idea of calculating water storage capacities and carbon calculations. So these are fairly primitive tools. We're looking at enhancing them with some more sophisticated modeling. For now, they're basically just things you could do with a spreadsheet or a calculator and some paper if you had the time, but this just streamlines the whole thing and lets you sort of get some sense of the total carbon value of your land given certain management practices moving forward. That's good for that slide. Thank you. So I'll lead into the challenge. I'll talk about the backdrop of AgSat, the cloud-free mosaics, or the base maps as they're called. So what we currently offer is 3-meter pixeled Esri world imagery. So this is a product from the ArcGIS guys or the Esri world community. So the problem is the same problem that we have with Google Maps, right? And that's that these images can be months or years old. So you might, if you do Google Maps and you get a satellite image of your house, it's like, well, the house next to me was actually built 2 years ago, but Google Maps is still showing it as a hole in the ground. So that what we want to do is sort of flip that on its head and say, well, what if instead of having high resolution imagery everywhere that was not guaranteed to be up to date, what if we did the opposite and had everything be very up to date, but not necessarily real. So a sort of pseudo reality or an augmented reality feel. And we want an improved solution to better suit the needs of our agricultural producers. We want to target rural Alberta as the testing grounds for this new feature, and we want to incorporate imagery from rural Alberta in the training data sets. So, next slide, please. So that's the whole crux of this thing, right? This machine learning challenge for Aquanty's use case is the idea of high apparent resolution. So not truly high resolution, but apparently high resolution imagery with machine learning. Though frequently refreshed satellite imagery is free, you pay nominally per download from S3 in AWS for Sentinel-2 satellite imagery. That's from the European Space Agency Copernicus project. It is too coarse for this use case being used as a base map. So what we can do is combine those images with high resolution spatial data available from the commercial providers. It's not commercially viable to just take high resolution imagery shots everywhere, cover all of the areas that we want to cover that are tens of thousands of square kilometers or larger, right? So the idea is to create this pseudo high resolution, if you will. So the idea is, given the challenge itself is given 10-meter input imagery, can we train on high resolution 1 meter or less imagery to provide at least a 3-fold enhancement to cloud-free coarse imagery? If you can do 5 or 10-fold, you might win. I don't know, but it's going to depend. And at the end of the day, Aquanty will handle taking the models and the machine learning pipelines, putting them into our processes and figuring out the stitching aspects ourselves. So we would deal with the stitching of the mosaic itself. That's not part of this challenge. So that's good for this slide. I'll just end on a quick note to drive this home. So there are repos you can find online that do this sort of thing already. Here's an urban shot, and the goal is to take this sort of blurry, it hurts my eyes image on the left and apply whatever you want, machine learning, convolutional neural networks, etc., and get to the nice crispy image on the right. And if you can screenshot and grab that URL, that this is actually an interactive demo with a screen divider that you can sort of pan and see the various features yourself. Okay, so I think that's my 10-minute talk. I'll pass it over to the host or Sadef.
Awesome. Thank you so much, Derek.